Good morning, everyone. So, before we start with the topic of today, I'd like to have a quick chat about the coordinate systems, etc., that we are also needing to deal with. And so, it seems that people are really getting stuck with this coordinate. I'd like to stress that using the diagram is essential. I've updated the slides for lecture 3 where this is now included. Previously you'd only have this picture rather than also the one with boxes. So I've updated that so to make your life a little bit easier. Of course you can draw this yourself, but you do need to actually think about how do you go from one line coordinate to the other one. So if you have this line, what is the box there? What is the box there? Obviously this one doesn't exist. But that's the idea. If you have a horizontal line, what's the coordinates of horizontal line? What's the box above? And what's the box below? You get the idea. What are the formulas? And if you get stuck, you may want to have a go at actually making it bigger in your own drawings. That should really help you. So do we have any other form of assessment other than the dot and box assignment? Yes, there is an exam coming up. So the exam will be 30%, will be multiple choice online exam. I'm not sure exactly what the logistics of it are going to be because it was intended to be a multiple choice in-person exam with just an answer sheet where you just tick some box, tick a pre-created answer sheet. But we will be doing that with Brightspace. So I have already transformed it into Brightspace, but the actual logistics of the exam will be something that will come later, so to speak. So I'm certain you will be hearing about that. When is the exam? There will be a timetable at some point published by the university. But that is normally after the lectures finished. So we still have 4 weeks of lectures, including this week. And that is the start of the exam period. I would be very surprised if it wouldn't be in the exam period. But we will be, I'll be trying to figure out how it exactly will work. And we'll tell you exactly what it will be. Does it matter what coordinate system you use for the boxes and lines? For the assignment, it doesn't matter. You want to have something sensible. The coordinate system needs to be internally consistent because the tests do look at coordinates, but they don't care about their particular values. You can't reuse the same coordinate for 2 different lines or 2 different boxes, obviously. That will not work, but you can use whatever coordinate system you find works well for you. So if you want to really do the coordinate system in the way that I discussed with using it as so having one coordinate system for boxes, dots and lines, you could do that. It's in my head it's a headache of doing that. It's harder than using the 2 separate coordinate systems, but if you really want to, you can do that as well. It's all whatever you find works best for you. The assignment doesn't care, and from a marking perspective, Only if it's something that's really dodgy would we want to do differently. Another point, by the way, for the assignment, that is start implementing the to-dos. There are many parts where, so the tests don't do only one property. Many of the tests hit a number of properties. So it's much more sensible to start implementing the game in a way that actually it should work. Think about what should actually happen here. What is the purpose of this function? And most of them are very simple. If you don't understand the purpose of a function, ask us. We'll be happy to help you. But the tests are there to check that it works correctly. They are not there to necessarily inform you about what the correct design is. And I found many students start with, okay, I need to have these tests. Sometimes people start implementing things and then they get less successful tests. Because some tests particularly it invokes a function, but if it doesn't do anything, it doesn't really matter for that particular test. So you might go down a little bit in the tests you pass. That's not very helpful. You can only really expect to pass the tests after you implemented all the to-dos. Many of them are easy. The hard parts are in things like draw line, where you need to make sure that you call the invoke run computer players. By the way, for computer players, you do use inheritance. To inherit from the computer player, you shouldn't be changing the player's file. But player is either a human player or a computer player. They are for your inheritance purposes. And because it's seal class, we know that it's only one of those two. So we can treat computer players specially and say, if it's a computer player, we will make them make a move. So if the computer has gotten a move, the expectation is that draw line will make this computer player make its move. So be aware of that. Okay, how do you get computer players to yes. How do you get them to take a computer player will also need to so if you look at the implementation of the computer players the turn thing, that one will actually, as long as the current player is a computer player, it will make it turn itself. So in draw line of the way to make this work correctly, if you do not have human players. By the way, this is not a requirement of the assignment because it's a bit tricky. But if that is the case, you only want to call the play computer players if the current player is a human player. Because that function that does the take another computer player turn, by the way, you can safely call it if the current player is a human player. It will just not do anything. But if it's a computer player, it will continue until there's no more. The current player isn't a human player, isn't a computer player anymore, or until the game is finished. So if there's only computer players, it will go to the next player. Oh, it's a computer player. Oh, it's a computer player. So it will continue playing those moves until there is no more, until the game is finished, and that condition becomes true. So to make that work correctly without exploding your stack, you don't want to call this function if the current player is a computer player, because the computer player is always invoked through that function anyway, so we use that loop. But again, this is not something that is required. If you call the play computer turns function and you are actually in a computer in a computer turn, it's fine as long as you have some human players around. If you have a human player, it will not become any problem with your application. Only you have no human players at all, will there ever be any issue with this? And in an Android game, it doesn't make sense not to have any human players. By the way, you can have 4, 5, 10 players if you want to. That should work. Be a bit odd how that works, how the gameplay works, but your application should be able to support that. Don't think I tested on that there. So, but yes, how do you so basically at the end of the draw line method, you say, am I a human player? If I'm a human player and I don't have to repeat, and I don't get another turn, we call play computer turns. No, it doesn't loop. It doesn't loop through that player list only once. It loops it infinite times. Basically, it asks, what is the current player? Of course, when you are through the player list, the draw line function needs to update the current player, including going back to the first one if the current one is the last one. The easiest way of doing that I find is basically just using the modulo operator. So something like next player equals current player index equals current player index plus 1 modulo players dot size. So this is the kind of function you would be using to set the current player index if you have such a property. Obviously, please be aware that I don't have the code in front of me right now, so names might be slightly wrong. I don't remember exactly what the names are that I used. But it should be fairly obvious which function I mean, which property. Of course, current player index is a property that you're suggested to create, but it doesn't exist. So this is the easier way of doing it. You can also use an if statement if you want to, but this is slightly more concise. And it will go back to 0 if we are actually having too many players. So this is how you get to the next player. So it loops through all the players. So yeah, so the only thing is that you first need to call it once to actually start playing the game, because it doesn't start. Okay, with the UI implementation, so how do you determine the box position, the line? So the suggested technique for handling presses is basically determine which box your press was in. So when you then have a box, you've got 4 bounding lines. You can get that from the bounding lines property. And for each of those lines, you determine the midpoint. So what is the coordinate in the middle of that line? So that determine, you need to basically use the view things that you know to know those coordinates. You have those coordinates because you needed to draw that line. You need exactly those coordinates. Then you have the midpoint. Well, it's a vertical one. It's, well, the half of the y. If it's a horizontal one, you do half of the x. Or you can do the average of the x and the y coordinates independently, whether it's horizontal or vertical, because it would just work. And then you just basically do the distance between that middle point of the line to the particular point that was pressed, and then you pick the one with shortest distance. And you may want to do things like, okay, if that distance is not overly longer than a certain size. In particular, if you want to allow clicks just outside the grid, you might want to allow that to work when you're not ridiculously outside of the grid. How do you do that? Yeah, well, you just set a maximum. Even if the smallest one is even too long, just ignore it. So that's So how do you determine the coordinates of a box or the lines? Basically, you have dot coordinates, so basically you need to figure out how long a line, how big the distance between two dots is going to be. The way that works is very similar to the way you determine the distance between two circles in the Connect 4 exercise. So you basically say, how much space do I have? How many dots do I need to put in there? Remember, or how many boxes do I need to put in there actually? Then I need to figure out how much extra do I need for my dots? And then you just do the math. You divide the available space by the amount of boxes, plus a bit of how big is a dot in terms of a box. And that's kind of how you determine the sizes. And you do that horizontal and vertical, and you pick the shortest one. If you want to make it really pretty, you then use that again to determine how big the size of your drawing actually is going to need to be, and you compare that with the size of your view, and then you can use an offset to basically you can calculate the difference and half that, and then you can center what you're drawing into that view rather than putting it in the top left. And then you add the offset every time you need to coordinate. You do add the offset. And so yeah, so where's the dot? It's in the top left and the right, etc. So you just derive all the things from how big is your box, and okay, here's a box, there's a box, there's a box. If you struggle with it, I would suggest you take a pen and a piece of paper and you draw the things, and then you say, okay, suppose the width is 47 pixels or whatever. Where would be the coordinate between this line, this line, this line, this line? What's the coordinate of this line? What's the coordinates of the box, etc.? And it becomes fairly straightforward fairly quickly. So draw it out and then draw the things, and then so one of the things you want to do is you want to record those things as attributes in your view, because you need them for touching as well as for drawing. The perfect place to do it is in onSizeChanged, because anytime the size of your view changes, onSizeChanged will be called with the actual new size. So it's called onSizeChanged. If you calculate them there, then you will certainly have the correct coordinates.